My name is Ed Barrett. I'm the Research Director of the Stockdale Center, where I research a different ethics topic every year. And it's a great pleasure to have Dr. Jim Giordano back with us. He's a senior fellow in our center and a professor of many things at Georgetown Medical Center, including neurology and medical ethics. So thanks for coming to speak with us on this integration and the relationship between neurology and AI and the ethical issues.
Always a pleasure. Thank you very much. Thanks all for coming. I really appreciate it. So before I begin, it's never good to start any lecture or briefing with an apology, but I have to, twofold. Number one, this is not a speech impediment. This is a New York City accent. I've been out of the city since '86, but I just had opportunity to talk to my old goombas on the phone this morning, so I'm sure it's very, very thick. And second, I guarantee you without fail, I'm going to drop into some terminology. It's going to sound like jargon. What I'll try to do is the way I usually do when I teach, which is say the word, define the word, use the word again. So if there's anything that comes up, either because you don't understand my speech impediment, any of you from New York, by the way?
Massachusetts.
That didn't count, but close enough, close enough. It's all right. So, and you're from New York, sir? Yeah, New York? Yeah, that's closer to Canada. You know the difference. Down in the city, we go, hey. Up there, you go, C-A. Comes after the word. It's all good. And the other thing is that if you don't understand the jargon, just raise a hand. So what I want to talk to you about is basically what we see here on the slide. I usually impugn anyone who would read a slide directly. You can. But I want you to read the slide by virtue of the intersection. They are not mutually exclusive topics, nor are they mutually exclusive in their iteration and their effect. We cannot do much of what we do in the biomedical sciences that are becoming ever more important to biosecurity, biointelligence, and biodefense without big data and some iteration of what's now being called AI. And what I want to be able to do is parse some of those things out and demonstrate to you this is a situation of right hand washing left hand and both washing the face. And it's also a question of whatever you want to put on your face. So this is infinitely corruptible. What I want you to take from the get-go is that all of these sciences have come together under a rubric that is now formally referred to as integrative scientific convergence. And as such, what we tend to do is now take these domains of science and clump them into functional S&T. So as you go through your respective careers, and for those of us who already are advanced in our careers, you're seeing the S&T moniker far more in a much diverse palette of utilization and real meanings. So whenever you see the S&T as the suffix, prefix that with whatever they have there and recognize this represents an integration of the science and the tools. And the reason for that is this is the big triune. There's a task sitting out there. What is the task? Whatever it could be. Do we have tools in our current armamentarium to be able to meet that task? Yes or no? Based upon that, in engaging that task, what do we know about that stuff? That becomes the theory. We come to the limits of those theories, boom, we need new tools. And then what ends up happening is those tools then allow us to reappropriate the task and reorganize the theory. So this idea of tasks, tools, and theory is very much like a three-partner dance, but can also be considered as part of the proverbial three-body system in physics that leads to particular imbalancing. As tools become more apparent, we make some tasks up for them. As we have tools that provide particular theoretical discretion, it then offers our capability to go deeper into certain tasks and back out of others. And the absence of certain tools in the face of tasks and theory, or the absence of theory, prompts us to make various tools anew. In other words, what you tend to see is an iterative and escalative use of theory and tools to be able to accommodate a range of tasks. This area, integrative advanced scientific convergence, a term first coined by Professor Ashok Vashasta, formerly at State Department, then doing a lot of deep intel work with DoD, now up at Rutgers University, recognizes that it brings together all of the sciences in a disiloed way. One of the problems with the sciences and other fields has historically been that they exist within a rather insular solipsistic science and or silo. I can tell you that from my own experience. I've been doing this academic thing for 42 years this year. And it was very easy early on to exist relatively in that silo, unpack what you had, and then hand it off. But increasingly, this task, theory, and tool interface is demanding, at very, very least, some diffusion between the silos, and more, a de-siloing altogether, which then opens up the opportunity space, the challenge space, the problem address and solving space, but also the problem space. Much of the problem has been that the information that is gained from one silo, domain or dimension, is not necessarily tractionable or palatable within the other by virtue of scale, level, focus, nexus, etc. What has made that far more accomplishable and realistic has been this thing called big data. And depending on who you talk to, big data is a thing or they are things. Yes, data are always plural. For the middies in the room, whenever you use the word data, put your pinky up in the air and always refer to it in the plural. People think you're educated. But big data is a singular thing. And what that singular thing is an enterprise, an edifice, in which various types of data acquisition, utilization, synthesis, dissemination, and increasingly security, ethics, and social issues are being addressed. You cannot do integrative scientific convergence without big data, because it allows the relative translatability and therefore tractionability of these different disciplines and the type of information they acquire to be shared, assimilated, synthesized, and utilized in relatively real time across massive scopes of data, levels of data, and this allows what we call the multiple V approach. Validity, veridicality of data, viability of volumes of data with high velocity, which all increases its value. But you can't do big data without some form of machine learning or decision technologies. And unfortunately, what's happened is the term AI has slipped into colloquialism within our general community parlance. Let me sort of dissect that a little bit for you, because I think by dissecting it, we can be far more specific as to where the benefits, burdens, and potential risks lay. Work from the bottom up. Deep learning represents not only a technique, but a series of technologies that allows us to essentially do as the slide does. It trains algorithms and systems by means of what's called neural network morphologies that are integrated. The way these basically work is they start out with a broad range of inputs that then funnel down in a somewhat pyramidal state and then allow that to then invert and go from a narrow focus to be able to get some information across a broad range of potential outputs. There's a lot of data exchange that occurs there. They're modeled on neurological systems across a variety of species, from literally sea slugs to humans. The more human they get, the more you get into something more like machine learning, where now a machine system acquires particular attributes, skills, talents, directionalities that a human user would imbue upon that system based upon the way you want the machine to learn to do things that are necessary for human cognitive, motoric, behavioral, or some other effectual end. Very often these two things are not mutually exclusive. Machine learning and some form of directed deep learning work together, and when you couple them together, you get primary AI, primary artificial intelligence. And so again, a formal definition for artificial intelligence is that it's an intelligent system that does so by way of some non-human interfacing of multiple systems of nodes and networks. The question is, how artificial is artificial? And what does artificial mean? Artificial not real, or artificial like artifice? And what we're finding is that if you take a look at this space, and this is the definable space, these things again are not mutually exclusive. So what we're using is more and more systems that incorporate a deep learning parameter, certain machine learning parameters to then have hierarchical and integrated deep learning, all of it fitted within what is necessarily AI. What this allows is this: a tremendous amount of informational capability, access, accessibility, affectation, use across domains. What are those domains? Look, it's all here. This interesting little diagram, which is microscopic to you, provides for you, if you will, the edifice of the way integrative scientific convergence has been realized, actualized, by the integration of both big data and various forms of deep learning, machine learning, and iterative progressive forms of AI, from relatively soft AI, which is these types of deep learning systems taken alone, to ever more autonomous and independent systems, which is harder AI, which we'll talk about in a moment. But you can see how this capacitates what we're able to do with information. It goes from the cellular to the social, from the individual to the international, across viable scales, across time spans, and allows for the integration of those data in ways from which meaning and representation of patterns can be extracted, either by the machine system and or by the human user. So there are two ways to do that. One is we can set up the machine system to be essentially agnostic. Look for some patterns here, and it'll pull those patterns out. The other is to be more gnostic. Look for this pattern, and it will do that. And of course, these are the domains and dimensions that are capable given these tools that we have at our discretion. Let me put this into some real world findings for you. What you have before you here is something called a von Mueller nodogram. A von Mueller nodogram. It's based upon a computational node network system originally developed at the Parmenides Institute in Germany by Professor Albrecht von Mueller, working with a neuroscientist named Dr. Ernst Pöppel. And what this essentially does is this take integrations of various types of data and brings them together in essentially a nodosphere. In other words, a sphere, an environment, an ecology of nodes that interconnect these data in usable ways. The one thing I've tried to do over and over again is try to get a slide that moves in 3 dimensions. I'm lucky I can get the damn PowerPoint up, so you'll have to just apologize for the fact that this is a singular dimensional slide. The way the nodogram works is fascinating because it takes each one of these domains not as circles but as spheres. And the contribution to that sphere is the acquisition of both prior as well as real-time data. All of these data, historical data, phenomic data, in other words, what is the physical nature of you, genotypic data, what is not only your genome and your genetics, but those of your historical family, those of those individuals who may influence your epigenome. In other words, what are your ecological and genetic interfaces? What are your medical economics? What are you buying at the drugstore? What prescriptions do you have? How are you using your social media, your public media? What are you reading? What are you downloading? What are you looking at your computer? What are your various contacts, both personally and professionally, and then ultimately using all of these to track your behaviors and from them map your cognitions in real time. In real time. A colleague who I work with, and I don't use this word ever cavalierly, truly a genius, named Professor Ophir Frieder at Georgetown, has taken the idea of the von Mueller nodogram and has utilized this for a way of naked person tracking. So if you know anything about human terrain teams in this dimension, in the DoD dimension or in the IC dimension, whether it's Title 50 or Title 10 applications, you know that one of the most difficult things is naked person tracking. How do we literally follow somebody without having identifiable characteristics that we can tag? Several years ago, our research group developed something called Titan, which was tiered integrative tag and analytic networks. But you still needed a tag. You still had to put something on that individual to be able to know where they were. Chip them the way you would your kitty cat or your dog. Now, can we do that? Yeah, we can. And all conspiracy theories aside about what happened yesterday on your cell phone, graphenes and nanobots aside, the truth of it is that we can. The real issue is we can introduce nanomaterials to you, to individuals, in a rather inconspicuous, if not clandestine, if not covert way, that are then trackable across domains and dimensions from the cloud and or from a satellite. But we still have to introduce the nanomaterials to you. Are there ways to do that? Yes. Some of them remain on the high side, some of them not so much, because this is now getting out into the public domain. But let's sort of take a step back. Let's say there's something sniffy about that. Oh, that's just a little too much big brother stuff. Well, we don't have to introduce anything to you to tag you and track you. You're doing it all yourself. I guarantee you're doing it all yourself. How many people in this room have one of these things? Got a GPS in your car, ever order anything online, go to the drugstore, they have your prescription, boom, there you go. And heaven forbid you use one of these situations like 23andMe or one of the other gene trackers. Good luck. All of that information is out there. You have an electronic medical record, look. You buy things, you talk to people, there it is. And this moves 3-dimensionally based upon what inputs, A, we're looking at, and B, what inputs are changing in real time, so as to be able to provide a 3-dimensional locus view of you that is patterned, physically patterned, as to what you're doing as these data evolve for you. Now, the reason I tell you that is you could imagine that this has a tremendous boon in a number of different viable applications, low-hanging fruit being benevolent. Medicine, various forms of social tracking, various forms of prospective tracking individuals in terms of risk factors, burdens, threats within their various environments. Certainly we can see this being used in combat scenarios so as to be able to provide what we call, in our research group, HOPE, health, operational protection, and enablement to do that job well and come back and survive. We can do that. We talk about a variety of preemptive risk factors. Can we now look at these things in advance and keep you as far out of harm's way as we possibly can? both by virtue of where we deploy you, how we deploy you, what we billet you into, literally segueing you into those particular billeting codes and those job spaces that are going to be most ideal and suited for what it is you're going to do, and ultimately it's going to be at best need to the service, if not the country at large. But we're not the only ones doing it. In fact, if you take a look at current dedication of gross domestic products to these areas of scientific and technological development that are focused into these exact silos that I've just spoken, the United States is actually number 2. Not number 1. We have number 1 in terms of our overall scientific and technological gross domestic product investment. We are followed closely, only $6 trillion off US dollars differential, by China. And if we actually examine how these key areas of large-scale financial investment are being channeled into key areas, domain areas that are representative of what I've just spoken to you about, the interface of big data, AI, and those things that have some form of, I'm going to drop a philosophical term, stand by, here it comes, biopower influence. For those of you who have a little bit of philosophical reading under your belt, French existential phenomenological philosopher Michel Foucault referred to biopower, exercising power by being able to gain insight and develop dependencies with individuals' biological necessities and essences. So in other words, there's something you need or something you are biologically, you need it, I got you. Now, what does this mean? What this means is that much of the edifice of American S&T that are dedicated to these enterprises is oriented towards playing some form of catch-up. We're not number 1. It's a precarious race. Right now, it's a photo finish, a Formula One photo finish. And in fact, we've used that analogy that this is very, very similar to a Formula One race. Big prizes, not only in terms of the money you're going to make by being able to utilize these in leveraging various markets, but big prizes of capability as well. High speed, huge high speed. The capabilization of being able to do big data with AI and a variety of applications that interface individuals' physical reality, their safety, their public health, ergo biosecurity and biodefense, is now moving ahead in quantum jumps every 48 calendar months. Break. Here in the United States, probably one of the most avant-gardistic research approaches to these types of things is exercised by the Defense Advanced Research Project Agency, DARPA. As you may know, DARPA utilizes something called the Heilmeier Catechism. What works, what doesn't? Why doesn't it work? Where doesn't it work? What's wrong with it? How much would it cost to fix it? And what's going to be the net profit gain across a number of viable domains as identified? That's the Heilmeier Catechism. According to that Heilmeier Catechism, utilizing those 5 principles allows us to then articulate that change from idea to instrument, from concept to construct in 5 calendar years, 60 calendar months. Our trans-Pacific near-peer competitor has an organization called Wingchewe Jiwei. Anybody who speaks any form of Chinese, any one of the dialects, is probably just going, God, no, that's not how you say it. But basically, it is a DARPA mimetic outfit. It took the DARPA model and incorporates it within the very seamless triple helix of Chinese political infrastructure, which is government, the research enterprise, which is academia, and the commercial sphere, so as to utilize those as a triune, which then pushes things through that system quick. How much quick? 42 calendar months. And if you think the difference between 60 calendar months and 42 calendar months ain't spit, you're wrong. That provides a considerable window of opportunity to be able to put a product or service or function out there, alpha, beta test it, utilize it in an employable way, and then retract it to watch what response is, and then modify it again very, very quickly. So that flexibility imparts fixity of purpose in a great way. And as you can see from this, realistically, that is then going to be capabilized within the next 3 to 5 years. There's nothing implicit about that at all. The Chinese government has come forth and said that realistically by the year 2049, a sentinel year historically, they will be the international leaders in science and technology, particularly with what they call biopolitical applications in markets, in tourism space, in research sharing space, to basically capitalize the global market on bioscience and tech. And their bioscience and tech is critically reliant upon big data and AI, as we see here. However, what you need to understand is this is a two-sided blade, folks. Any of these things that I just described being capable to do this kind of stuff, to hit the benevolent, low-hanging, beneficent fruit of those things that are going to be good for you, can also be used in ways that might be burdensome for you. risky for you, threatening to you, harmful for you. The more I know about you, the more I can develop stuff like precision pathologies. The more I know about where you're going to be in the next 10 minutes, the more I can put myself there. The more I know what affects you cognitively, emotionally, behaviorally, based upon those patterns of your big data and the integrative algorithms that I'm able to generate about you, or as you used to say in my hometown back in New York, all yous, individually or collectively, the more I can create narratives, symbols, iconographies, patterns to affect the way you think, feel, and act. It's not science fiction, it's real. China calls this one of their three warfares: psychological operations, media, and law. And the Chinese triple helix protects these types of scientific and technological developments under the veil of commercial entities and intellectual property laws. So, in many ways, it's requiring a stance on our part, the United States and our international economic, technological, and military intelligence allies, to engage a process known as deep surveillance, which is a nice way of saying we have to go high side. Because the regular superficial surveillance of pulsing literature, development, talent flow is not indicative of the actual capability that is being rendered here. And they're not alone. As you can see from the slide we have here, our transatlantic competitor is also deeply involved in this space, although their posture is a bit different. They're far more clandestine and less overt. They don't necessarily make the same claims about outward and very capable resituation of going to be their global position in the next 5 years. But just based upon the effects of the election that occurred in 2016, you know they're capable of doing these things. And the amount of information that is also viable and available to these individuals and their proxies of personal and collective value is growing. One of the other issues that comes to the fore that is very important is, what does this actually mean in the way we use the AI? Is anybody familiar with a program that's begun here in the United States called the Replicator Program? Show of hands. It's a DoD program to be able to create autonomous devices that are then usable in various forms of both kinetic and non-kinetic engagements. That's a really fancy way. You familiar with that? Can you tell us a little bit about that?
I only know that it's related to drones, and they want basically to be able to produce enough drone platforms that they are attritable.
Yep.
Which is a fancy way of saying that we can lose them and we don't care.
That's it. But not just drones. Autonomous drones. Drones that are essentially programmable to do something and then release them. Which is interesting, because the stance for autonomous drones across a variety of different media, whether it be unmanned aerial vehicles, surface vehicles, maritime vehicles, essentially reflects the underlying philosophy of how these devices should be developed and used. We, in the, quote, West, are very comfortable, if not feel very secure, with humans being in the loop, particularly when it comes to things that engage the possibility of weapon system use, or whatever other form of human interface is going to be involved that could be either beneficial, burdensome, or injurious, yeah? We like this very much. However, increasingly what we're realizing is that humans are, at least in part, a relatively weak link in the articulative chain, if for nothing else, based upon decision speed. The information has to come back to the human user, has to be integrated through a set of human channels, has to be fed back to the device, and then the device has to articulate and implement. Sometimes you just don't have that kind of wiggle room. However, a human on the loop might be able to provide that in a proactive way, where the system is essentially what we call prescinding. In other words, stepping out of itself to give a God's eye view. This is what's going to happen next. Heads up, human. You're on the loop. Be aware. We need to call you in now. So in other words, you're waiting outside the door for the machine to go squawk. In you come and go, oh, now we've got an issue. Let's deal with this. That's on the loop. However, increasingly in international circles that deal with this type of technology, humans are out of the loop. Why? Because humans are seen as an impediment to the iterative progress of the instrumentative development of these technologies. Why put in human builder biases when those builder biases essentially fold in all the foils and foibles of human decision-making process when we're leaning on the machine to do something that we want it to do better than us, but what we're really doing is we're hobbling the machine to do that. That would be sort of like putting great shoes on the horse and then making sure the horse runs to my own pace. Huh? Our trans-Pacific near competitors are married to the idea of humans out of the loop for any and all forms of AI. And the reason is simple. because they actually feel and have stated explicitly in the literature, both technical literature as well as philosophical, political literature dealing with science and technological development, that humans out of the loop carry only the primary directive of the initial human in the loop, which is basically a political directive that then allows these machine systems to articulate, not my term, pure cognition. Pure cognition. Now, is that inherently problematic? Is that, as we like to say in the medical, legal, and ethical legal realm, malum in se, bad unto itself? No, not necessarily. And part of the problem is defining what is bad unto itself and what is not, and how these things are going to be used, which obviously poses the issue of security, risks, and potential threats for which all of these systems, taken either individually or, more realistically, in combination, pose. Look at what these things are capable of doing. These are all of the downrange, real-world, viable options that these systems, as they exist in 2023, essentially accommodate and operationalize. Massive data and multi-level and situational surveillance. This gets back to the human terrain, teaming, tracking, and naked person viability and tracking. Real time. Number two, security and defense gaming to a level and extent that heretofore was not possible, which now allow us to map, identify, access, and affect potential competitors, adversaries' vulnerabilities. And those vulnerabilities then allow for an increased level and fidelity and granulation of what's called vulnerabilization of competitors and foes. In other words, if I just look at this individual, I may think this is a naval aviator, completely without any weaknesses whatsoever, knowing that community well, flawless, perfect in all iterations of cognition, emotion, behavior, and physiology. Easy. Come on now. All right, there you go. And I can say, well, sitting right next to him, look at a trident. Absolutely, this represents the pinnacle of the Special Operations Command community for the United States Navy. Obviously, just as flawless in so many different ways. We're not even going to go into subby stuff, but that's different. It's okay, don't worry about it, we'll get there. And one might make that assumption based upon literally performance records, history, training, etc. And as tongue-in-cheek as that is, but what if I really knew that he was afraid of spiders? Or the moon? Seriously. Something what appeared to be benign and infinitesimal. What it allows me to do is target individual vulnerabilities. And by targeting those vulnerabilities, what have I got? I got the weakest link, albeit a nano chink in that chain, by which I can then manipulate. And if I can access it, I can affect it. Can I assess it? Absolutely I can. But there's more than that. One of the things I might also be able to do is manipulate data in such a way as to make it seem as if his particular arachnophobia, or the fact that this gentleman is afraid of the moon, has been a long-standing psychiatric problem throughout their family and has debilitated their family in so many ways that obviously makes this individual very, very vulnerable if placed in a high-security situation, because all Ivan has to do is show them, look, nasty spider, next thing you know, boom, he's going to be spilling his gut. And he comes back and says, this has never happened in my family. I've never had a complete decompensation, anxiety profile, PTSD, because I was attacked by a spider. Oh, yes, you do. It's right here in your data. I have your data. But that's not real. Prove it. Prove it. Now, I'm being really overt, but it could be something like your medical record, where your vulnerabilities lie. Are you qualified for service? Are you qualified to hold a clearance? Are you qualified to vote? Is there a criminal record in your past? A psychiatric record in your past that might be physically non-qualifying? Do you have an existing medical condition that requires treatment path alpha when in fact you don't have that condition and you really need treatment path bravo? Now what's happening is you're getting all the wrong treatment. And speaking of treatment, if I know what makes you tick, if I know where your vulnerabilities lie, I can also utilize all of these big data AI systems together with some of the state-of-the-art synthetic bio and gene editing techniques to be able to develop precision pathologies. Designer bugs. Everything I have read, no guilty knowledge here, it's now low side, both high side and now low, about SARS-CoV, the SARS virus that created the global pandemic that we just have gone through and continue to go through, indicates that this was not an intentionally manufactured biological weapon per se. It was a hiccup in the biosecurity level of laboratories that were doing something called gain-of-function research. The wake-up call is, we can do this. Fast, fast. We can also redirect narratives. I had the pleasure and honor of being involved in a DARPA program called Narrative Networks, that by understanding how individuals' brains work in response to various cognitive patterns, cognitive stimuli, and then clumping them together in big data AI patterned ways, we can understand what sort of trips your trigger, what tickles your Twinkie, what lights your fire, what pisses you off. And as a result, what I can then do is manipulate various narratives and symbols to do that. You don't believe me? Look at TikTok. And of course, now we go back to the idea of autonomous weapon systems. Being prepared for this doesn't mean we can't go forward with this. Doesn't mean that we have to prohibit research, technology, development, and use among the United States and our international market, technology, and military intelligence allies. But what it does mean is we have to go through with a process of being prepared to go there. In other words, we must be focused, flexible, fast-moving, and rapidly adapting. It's the only way we can move forward. We don't want to prevent the good things that come out of this, if you will, jar of genies, but by the same token, we don't want the gremlins to come out, nor do you want to sprinkle them with water at midnight. One of the things we've advocated is what we call the SMART approach. Obviously, administration, management, security, education, training, sort of like voting in Chicago, early and often throughout individuals' career, militarily and otherwise. But one of the things you also have to be aware of is that as deeply nested as this is in understanding the science and technology, it cannot nor should not be extricated from the philosophical, cultural, and ethical frameworks in which it lives. Our international peer competitors have learned to utilize their long-standing cultural histories, philosophies, and ethics to profound scientific and technological global advantage. I've sat on those committees. I've listened to the rhetoric, and it goes like this. Yes, for hundreds of years, the West was the predominant force with regard to worldwide science, technology, and philosophy, because the West has failed to recognize the cultural appropriateness and probity of the long-standing Chinese culture that has existed for thousands of years, which, to our view, from inside China, is just as important, just as sentinel and salient as the long-standing Western philosophical tradition that you hold near and dear. And, by the way, part of that Western tradition is an openness to multiculturalism and a relative embrace of sort of cultural concerns and responsivity. Why are you not doing that now? And I'll tell you why you're not doing that now, because it puts you in a decremented position, because you're not allowing us to respect our ethics that's somewhat more permissive than your own, even in terms of definitions of what constitutes basic human rights and what needs to be repaid back to the collective, the community, the state, so as to be able to reinstate one's human rights as a human. And there are ways to do that. One can be involved in human research, for example, and or various forms of service. That permissiveness is also open worldwide. Come to here, wherever here may be. I'm using China as an example. And you can get a lot of work done that you couldn't ordinarily get done in your own country. Is that ethics dumping, or is that scientific and technological opportunization? But the bottom line of that is it also then becomes Chinese intellectual property, which then leverages these non-kinetic markets in these particular ways. So how do we go forward? I'm going to tell you how you go forward. At least I'm going to give you the ticket. And the ticket starts right here. Cash the reality check. Nothing I have told you in this brief is science fictional. It's all science factual. Nothing that I've told you here is cultural clutter. It all represents cultural and cosmopolitan realities of the 21st century global stage in these domains of science and technology that are leverageable across a variety of others and are certainly actionable in those ways that we feel poses at least some potential risk, if not clear and present threats and dangers, to various domains of national security, intelligence, and defense. That kind of realistic insight is going to be important. Savvy to the actual technology and the economics, equally important. Building security by design into each and all of these domains of the science and technology as a component of not only their creation, but their sustainment in terms of the edifice and enterprise that they execute, and also being responsive to these global ethics. Ethics needs to be an inextricable part of any and all education, research, and training in these dimensions so as to be able to be operative in a realistic way on the global stage of the 21st century. I have a little bit of time for questions. If you want to take a deeper dive, I provide you with these readings. This is some of the work that our research group has been doing in tandem with a variety of international partners over the past 10 years. And if you want to get in touch with me, you don't have time here, you need to get off somewhere else. I appreciate the constraints on your schedule. You can reach me here at james.giordano@georgetown.edu. Order right now and I can get you a tin hat so this stuff will not affect any of you. Thank you very much for your time. Thank you. Sir, we have time.
One question, the midshipman probably have to get going.
Oh, roger that.
Yeah.
Sir, can we see the slide before this?
That one?
Oh, okay.
Can we make the PowerPoint available to students, sir?
Yes, it will, yeah.
There you go.
Can you stick around for questions after?
Absolutely.
Okay.
Thank you all for your interest in the information I have. I hope you found it informative at the very least, and perhaps maybe a little interesting, entertaining, and frightening at the extreme. Thank you much. Thank you.